part C, notice that n is again our length of the array, and then we have these two cases. So if a of 0 is equal to 10, then we're going to be doing this for loop where we start from I equals 0, go all the way to n squared, and then we're going by increments of 5. And so basically the number of total iterations is going to be n squared divided by 5, which is basically equal to n squared, because remember the constant factors are taken out. And then the second case is when we go from 0 to n squared again, but now we are jumping by times 2. And so this is actually going to be similar to how we find, let's say if we're going from 0 to just n, and we're times by 2 every iteration, then that's going to give us log n, right? And the reason it's log n is because we're basically interested in finding how many times can I divide n by 2 to get down to 1, right? And so basically k is going to equal log n after you do some arithmetic. And this is going to be the same case here. So this is now n squared. If we want to solve for k, then we have to multiply both sides by 2 to the k, which is going to get us n squared equals 2 to the k. To get k down from the exponent, we need to multiply log on both sides, or take the log of both sides. And so it's going to be log n squared equals k times log 2. And in general, you can assume that the base of a log is 2, which means that this is going to become 1. And then we basically have k is equal to log n squared. Remember that the exponent can always be come down, right? It's basically k equals 2 times log n, which is really just equal to log n, right? And so we figured out that if we enter the if case, we're going to have a runtime of theta n squared, and if we enter the else case, we're going to have a runtime of log n. And so the best case is going to be the log n, and the worst case is going to be the theta n squared.